A vocab question on the math? Say what? That's what this is. They want to know, do you know what x-intercepts are? And do you know what zeros are? And do you know what cubic versus quadratic means? So we're going to break all this down. I put on here a very simple, the simplest cubic function that I can think, I'm sorry, quadratic function that I can find, which is just 1x squared plus 1x plus 1. And this is a good one because we see that it doesn't cross the x-intercept. Why is that important? Well, they want something that crosses no x-intercepts. Now, this is a no calculator section. I'm not saying you need to pull out your calculator and do this, but I want you to understand what I'm mentioning here as I go through the vocabulary. So if you're crossing the x-intercept of the x-axis, that means you have x-intercepts. This is not doing it. It has one y-intercept at 0, 1. That's irrelevant for this question. So let's go through each of these answers because they want to know which one of them has no x-intercepts. Well, a linear function whose rate of change is not 0. Well, to have a linear function that has a rate of change that is not 0, so that means that can be y equals 1x because our rate of change, rate means that we're multiplying by something here, 1 times x. That is going to have an x-intercept. It's going through the origin, no matter what I change the y-intercept to. Here it is. What if I made it negative? Doesn't matter. Still, it's going to give us that. So it's not going to be a quadratic function with real zeros. Well, to have real zeros, I can make our intercept here negative. So I can say -1, and here it is. And what they're testing you on is that, what does it mean to have real zeros? Zeros is synonymous with x-intercepts. This is one of those things in math that I think there was just a bunch of nerds that said, I want to call them zeros. And someone's like, well, what about x-intercepts? And we're like, well, your name's, I don't like your name. My name's better, bro. And now there's x-intercepts, real zeros, and there's one more that I'm just blanking out on right now, but there's like a few names for these. Roots, that's the other one, roots. And so it's, just know that when you see roots, zeros, and x-intercepts, that's lo mismo. It's the same thing. So if it has zeros, that means it has x-intercepts. It can't be b. A quadratic function with no real zeros. Well, that's where we were essentially at, and this turns out to be the correct answer. But let's see, why is it not D? Well, a cubic polynomial with at least one real zero, so that means it has at least one x-intercept. And to be a cubic polynomial, that means that's no longer 2, but that would be 3. And it kind of makes this shape. Instead, it's like a parabola where one side just gave up. And it hits x right on there. So that's not going to fulfill our necessity of this problem.